I'm going to move that understanding check back to, let's say, Monday. And I will also make the M1-77 due on Tuesday instead of tomorrow.
So
you still need the graphic organizers done for to turn in tomorrow, but you just need the graphic organizers tomorrow.
So I was saying,
yes.
Yes.
Okay. So once again, what is due tomorrow?
M1-73.
Those graphic organizers, M1-73 through M1-75. What is not due tomorrow?
77.
M1-77, right? The write and the practice. Now you can still go ahead and look at it, and I do recommend that because I will give you a chance to ask questions tomorrow. Also, we're going to have the understanding check that I planned. No, when we're going to have that? Monday, okay. So let's look at B here, and I will say the reason why I'm doing this, please hear me very clearly on this, I am moving this back because y'all worked the whole time. Well, most of us, Gracie, worked and talked the whole time. Just kidding, y'all worked most of the time. There was a few conversations that weren't math related, but were y'all, I'll come get in a second, were y'all actively engaged in trying to make sense of the math? Yes. One, I do want to point out, was it more fun when we talked with each other and actually made and talked about it, trying to make sense of it? It keeps us up, right? When you have a teacher just lecturing to you, it's pretty hard to stay awake. And when you talk about it, you're going to learn it better, right? There's a reason why I teach the way I do. I need y'all to engage and participate. You will learn more this way. And I'll hear your ideas. I'll be able to catch some mistakes that we're making, so that's great news. All right, so which of these equations do we think could be graph B?
F1.
So F1, does anyone want to push back on that, or do we all agree?
We all agree.
All agree? Okay, any more?
F3.
F3? Does anyone want to push back on that, or do we all agree?
It's standard. Never mind. That's
You don't
it.
know the A, right?
B, graph B. So do we, I hear some people trying to push back, yes or no?
You said 3, yeah. I think it could be standard.
Okay, so it seems like there's not 100% uniformity on that, so why are we thinking yes? What details do we notice? So it's a positive y-intercept. Specifically, what is the y-intercept? 0, comma 240, right? So that works, that's a positive. Anything else that we want to notice?
Oh, the C? Oh, no, you're right.
And it's concave up, right? Because that is a positive. So, do those details match the graph? Yes. But you changed your answer, you got one? Oh, so y'all originally had is no? Feeling comfortable with that now? Good. All right, so it's great to learn from our mistakes. Any others that we want to say yes to?
No.
No.
No others?
Wait.
No.
Well.
No.
Okay. Okay. So really quickly, I do want to point out a couple things here, right? So we want to notice this. This x-intercept would be A. This x-intercept would be positive or negative? Positive. This one would be negative, right? So that doesn't match the fact that it's supposed to be two positives. We good there? Okay. Here, I think that vertex would be fine, right? 75 comma negative 92. So what's the issue? It's concave down, right? So we want to note those things to make sure we understand them well. Okay. Now, one last detail. Actually, there's two last details I want to point out. Here, when we look at F8 and F2, there is no number written in front. So what's it understood to be? Positive 1, right? So it is an understood positive 1. And Nathan had a great question about this earlier. He asked, can the A be 0? Right? Because it's not there, so could it be a 0? So let's talk about what would happen if A was 0. A times x minus R1 times x minus R2. It doesn't matter what R1 and R2 are. What's anything times 0?
0.
So would that be a parabola?
I thought A was the concavity, right?
It's not the concavity, but it is telling us whether it's concave up or down.
Yeah, but what point on it is it? Like
It's
on
not a point on it. That's the point.
okay, on the desert, like you can move the little thing.
So
around.
remember, like the y-intercept, the vertex, the x-intercepts, those are points. But did we ever talk about concavity as a point? No. Concavity is just whether it's going concave up or concave down.
I was thinking the little
Okay.
point right there, I was saying if that was 0, you could do it, because it would just start on the x-axis and go up.
So here is standard form. If a is 0, what's 0 times x squared?
0.
Is that going to be a quadratic? No. That's going to be slope intercept. That's going to be linear, right? And so then if I look at the vertex form, 0 times x minus h squared plus k, what is 0 times anything? And then I get 0 plus k, so I get k. Is that quadratic? No. So if a is ever 0, is it a quadratic function? No. Does that help clarify it for us? Okay with that? Say it one more time. It's not, no. We're saying that a cannot be what number? 0. Right? If a is a 0, it's no longer quadratic. That's the point I'm trying to make. So a very much matters, because remember, if a is positive, it's concave up, and if a is negative, it's concave down. Okay, so from there, the last thing I do want to point out is this. I feel like some of us are struggling a little bit with the y-intercept or on the standard form, things like that, but I do want you to notice this. In standard form, it's ax squared plus bx plus c. And what should we always know about the x value of a y-intercept? The x value is 0, right? So looking at here, I get 0 squared plus 6 times 0 minus 2. I want you to notice, because it's ax squared plus bx plus c, if I substitute a 0 into here and a 0 into here, what is always going to happen to this part right here? It's going to become 0. For an or for a y-intercept, this part always becomes a 0 in standard form. That part always becomes a 0 in standard form. So then what am I always left with for the y-intercept? What's 0 plus c? C, right? So if we substitute a 0 in to find that y-intercept, I'm always left with c. And I do want you to notice this. It's always plus c. Whenever it's a plus, you just take what sign it is. When it's an x minus, that's when you do the opposite. Notice, if I substitute a 0 in, I get negative 2. Did we get the opposite in this case? No. It is just that negative 2. Right? Because what kind of number did I have to add in order to get minus 2? I had to add a negative 2. Right? I had to add a negative 2 in order to get minus 2. The only time it's the opposite is when it's x minus h, or x minus r1 or r2. Any questions before I continue? No? Okay, for those of us who already got to part C, which of these functions could it be? F3 and F5? Okay. I want to point this out. Before I even do a single thing, I knew it couldn't be F1 or F4. Does anyone have a reason why?
Excuse this interruption. This is an all call.
Shannon?
We need Harmony Cooper to come to the office. Harmony
Or you know
Cooper.
that you're gonna change your negative and your positive, and it don't go out, it don't work out. That's all I know.
Okay, kind of.
Yeah, so the 5 would still be negative, so it wouldn't be concave up.
No, it'd be a positive 5.
It would be a negative 1.
A positive 5 what?
0.
It'll be,
So what point are you talking about when you say 5 comma 2? Look at your graph again. Why did I know they didn't work?
There's nothing on the x-axis.
Yeah.
Say again.
There's nothing on the x-axis.
Do we ever even intersect the x-axis?
No.
So if we don't intersect the x-axis, what kind of points don't we have?
We don't have
X-intercept. So can we have a factored form there? No. That's what I recognize right away is, hey, that factored form is giving me x-intercepts. I don't have any, so I can't have a factored form. This is where we'll pick up tomorrow. I do want to, before you pack up, I want you to make a note to yourself here. It says, consider the two functions shown from question 1, identify the form of the function given, and then write the function in the other two forms, okay? We're going to do this, but anyone have an idea how we can get standard form from this?
Can you distribute?
You can't distribute, just multiply. I would distribute my binomials first. Be careful. Do not do negative 2x minus 2 times negative 2x minus 8. Don't do that. That's multiplying negative 2 times both things, but you only need to do it times 1. That's why I would do the binomials first. But distribute, simplify. That is where we'll pick up tomorrow, and then I will show you how to get the vertex form from factored form and the factored form from vertex form. No, ma'am. Hold on one second. I will say yes in a second, but thanks, sir. Okay, so homework that is due tomorrow. What did we take off? M1-77. When does that due? Tuesday. The graphic organizers. When are those due? Tomorrow. Obviously, we're not going to be finishing up lesson 5. We'll finish up lesson 4 and start lesson 5. And then we'll start with a quick understanding check on the forms of quadratic equations and the revealed features on Monday instead of tomorrow. Yes, LaShane, what was your question?
What do we do for tomorrow?
Well, remember the understanding check's not till Monday now.
Y'all tomorrow. Work tomorrow.
So we're going to finish up lesson 4.
We're not gonna be here.
I know. We're going to finish up lesson 4. We're going to start lesson 5. I don't know exactly where we'll get, so watch the videos to see.
Okay.
Yeah. But then just be aware, it's going to be lessons 4 and 5.
Okay.
Just not sure where we'll get.